how to access our website. Go to any browser and type search creators. Click on the first link. Now you have entered our home page where 50k plus study materials are available along with 1000 plus project ideas. We have 10 plus expert members in our team and we also support 50 plus engineering domains. In navigation bar, select University Study Materials. There are three streams available: computer science, information science and artificial intelligence and data science. For now, we will click on computer science. Now we will be able to access all the study materials of different subjects of different semesters.
Hello everyone, welcome back to Search Creators YouTube channel. In this video, we are going to look at the last topic in Module 2 of Cloud Computing, which is Virtualization for Data Center Automation. In this, we are going to look at growth of data centers. Before moving into this topic, we will know about different data centers like major IT companies like Google, Amazon, Microsoft, HP, Apple, IBM. Like these are most like popular type of major IT companies which have invested in data centers. Like millions of dollars are spent on data center construction and automation. Now, in this video, we are going to look at the virtualization for data center automation, like how virtualization works with data center automation. As I said, major IT companies like Google, Amazon, Microsoft, HP, Apple, and IBM are invested in data centers. Millions of dollars are spent on data center construction and automation. Like major IT companies, the most popular ones are Google, Amazon, Microsoft, which are invested in data centers. Like billions of dollars are spent on data center construction and automation. Automation enables dynamic resource allocation for millions of users with QoS and cost efficiency. Like automation enables dynamic resource allocation. Like resource allocation is dynamic, like it is not static for millions of users with QoS and cost efficiency. Next, we are going to look at role of virtualization in data center automation. Next, we are going to look at the role of virtualization in data center automation. Virtualization and cloud computing drive automation. Like virtualization and the cloud computing both drive the automation. Now we are going to look at market growth from 2006 to 2011. In 2006, 1.004 billion market share dominated by production consolidation and software development. Like in 2006, 1.004 billion market shares were dominated by product consolidation and software development. In 2011, like projected, 3.2 billion market share expanding into high availability, utility computing and workload balancing. Like in 2011, 3.2 billion market share expanding into high availability, utility computing and workload balancing happened in 2011. Virtualization reduces planned downtime and enhances mobility and scalability. What virtualization does is it reduces the planned downtime and enhances the mobility and scalability of the growth. Next is developments in virtualization. The developments in virtualization are high availability ensures system uptime. Like higher availability ensures system uptime. Backup services improve disaster recovery. Like backup services provided will improve the disaster recovery. In case the some data have been erased, we can by using backup services we can recover the erased data. Workload balancing optimizes resource allocation. Like workload balancing will optimize the resource allocation. Service oriented automation and policy based management enhance efficiency. Like the service oriented automation and policy based management enhance the efficiency. Next, we are going to look at server consolidation in data centers. Workloads are categorized into chatty workloads and non-interactive workloads. In chatty workloads, fluctuation demand, for example, video streaming at night. Like in chatty workload, we can see fluctuating demand. In that, for example, you can say video streaming at night. In non-interactive workload, consistent demand. For example, high performance computing. Like in non-interactive workload, we can observe consistent demand. An example for non-interactive load is high performance computing, which is HPC. Problem is underutilized servers waste resources like hardware, space, power, management, and costs. Like underutilized servers waste resources. Like this is one of the problem. Hardware, space, power, management cost are wasted. Next is solution. Virtualization based server consolidation optimizes resource utilization. The solution for this problem is virtualization based server consolidation optimizes resource utilization. Next, we are going to look at the benefits of server virtualization. Improves hardware utilization by consolidating multiple servers into few machines. Like it improves the hardware utilization. How means like it consolidate multiple server into fewer machine itself. By this, it improves hardware utilization, enhances disaster recovery and backup services. Like it will enhance the disaster recovery and backup services. Next is reduces total cost of ownership, which is TCO, which means fewer servers needed, lower maintenance, power and cooling costs. Like when fewer servers are needed, maintenance will be low power is needed, and cooling cost will also be decreased. Next is improves availability and business continuity. Like it will improve the availability and business continuity. Like in guest OS crashes do not affect host OS or other virtual machines, and virtual machines can be migrated between servers seamlessly. Like these are some of the benefits of server utilization, like server virtualization. Next is automated resource management in virtualized data centers. Key factors are resource scheduling and power management. In automated resource management in virtualized data centers, the key factors are resource scheduling and power management. Next is performance optimization through analytic models. Like performance optimization can also be done through analytic models. Scheduling levels like VM level, server level, and data center level scheduling can be done. Next is dynamic CPU allocation. Based on virtual machine utilization and application QoS metrics, two-level resource management using local VM level and global server level controllers. Like in dynamic CPU allocation, which can be changed over time based on virtual machine utilization and application QoS metrics. Like the it works on VM utilization and application based on QoS metrics. Next is two-level resource management using local and global controllers. Like two-level resource management is done using local like VM level and global, which is server level controllers. Next is challenges and future scope. Optimizing memory management in multi-core processors, which are CMPs, like optimizing memory management in multi-core processors. Next is power budgeting strategies to balance power saving and data center performance. Like power budgeting strategies should be done. Next is inter VM communication and memory access protocols to enhance efficiency. Next is server consolidation in data centers. In that, we are going to look at the types of workloads in data centers, which are chatty workloads, non-interactive workloads. In chatty workloads, burst at peak times and remain idle otherwise. Like in previously we observed what chatty workloads are. Like they burst at peak times and remain idle otherwise. It means there is no constant demand for the chatty workloads. For example, webbook video services. Next is non-interactive workloads. They do not require human intervention after submission. But in non-interactive workloads, there will be constant demand and it does not require human intervention after the submission. For example, HPC, which is high performance computing. Next is challenges. Workloads have different resource demands leading to underutilized servers when resources are allocated for peak demand. Like some of the challenges are workload have different resource demands which lead to underutilized servers when resources are allocated for peak demand. Like this is the challenge in the types of workloads. Next is problems with static resource allocation. Servers are often underutilized, wasting hardware resources, space, and power management cost. Like earlier, we observed what and all underutilization servers can do. Like they can waste hardware resources, waste space and power. They can also increase management costs. Resource optimization is needed at level of CPU, memory, and network interfaces. Like resource optimization is essential at the level of CPU, memory, and network interfaces. Next is virtualization based server consolidation. What are the key approach in virtualized based server consolidation is reduces the number of physical servers while optimizing resource use. Like the key approach in virtualization based server consolidation is that it reduces the number of physical servers while optimizing resource use. More effective than other consolidation techniques like centralized and physical consolidation. Like they are more effective than the other consolidation techniques, for example centralized and physical consolidation. Next is virtualization allows fine-grained resource allocation, improving flexibility. Like the virtualization will allow fine-grained resource allocation. By this, it improves the flexibility. Next is the benefits of server virtualization. What and all the benefits of the server virtualization are there? First is enhances hardware utilization. Like underutilized servers are consolidated into fewer machines. Like by this, it enhances hardware utilization. Next is facilitates backup and disaster recovery. Like it facilitates the backup and disaster recovery. Next is improves agility in resource provisioning. Like VM images can be cloned and deployed quickly. By this, it improves agility in resource provisioning. Next is reduces total cost of ownership, which is TOC. We have seen this before also, like fewer servers. By this, lower maintenance, lower power, less costs in cooling and cabling costs. Next is it improves availability and business continuity. This also we observed above, like guest OS crashes do not affect host OS or other VMs. Virtual servers can be migrated seamlessly between physical machines. Next is challenges in virtualized data centers. Next we are going to look at the challenges in virtualized data centers, which are resource scheduling complexity, needs optimization at multi levels. Like in challenges in virtualized data centers, we can observe resource scheduling complexity, which needs optimization at multiple levels. These different levels are VM level, server level, data center level. Next is dynamic CPU allocation. Based on VM utilization and application level QoS metrics. Like dynamic CPU allocation is based on VM virtual machine utilization and application level QoS matrices. Adjusts resources automatically for varying workloads. Like dynamic CPU allocation adjusts resources automatically for varying workloads. Next is two level resource management. In this local controller which is VM level and global controller which is server level works together for autonomic resource allocation. Like in local level it is VM level, like in global controller we have server level. Both of them work together for autonomic resource allocation. Next is multi-core processor and virtualization. Challenges in CMP like chip multiprocessing, which are memory systems are not fully optimized for virtualization, need to reduce memory access time and minimize inter-VM interference. Lastly, VMware power budgeting required for balancing power saving and performance. Like these are all the challenges with CMP, which are memory system not fully optimized for virtualization, need to require memory access and minimize inter-VM interference. Lastly, VMware power budgeting required for balancing power saving and performance. Next is future consideration for optimized virtualized data center. Like next we are going to look at the future consideration for optimized virtualized data centers. Improving inter-VM communication protocols, enhancing memory sharing and management in CMP based servers, integrating power management policies with VMware scheduling, addressing heterogeneity in workloads for better performance and efficiency. Like these are all the future consideration for optimized virtualized data centers. Next is virtual storage management. In virtual storage management, we are going to look at storage virtualization and system virtualization. Firstly, traditional storage virtualization. Aggregation and repartition of physical disks for used by physical machines. Like in traditional storage virtualization, aggregation and repartitioning of physical disks for use by physical machines itself, like it is the traditional storage virtualization. In system virtualization, virtual storage includes the storage managed by virtual machine monitors, which are VMMs, and guest OSs, with the data classified into two categories. Like in system virtualization, virtual storage includes the storage managed by virtual machine monitors and guest OSs, with the data classified into two categories, which are VM images and application data. In VM images, it's specific to virtual environments. Application data is similar to traditional OS environments. Next is challenges in virtual storage. Encapsulation and isolation. Like VMs provide isolation between guest OSs, allowing multiple VMs to run on a physical machine. Like virtual machines provide isolation between the guest OS, allowing the multiple virtual machines to run on a physical machine. Storage systems struggle to keep up with system and CPU advancements, becoming bottleneck in VM deployment. Like storage system will struggle to keep up with the system and CPU advancements, becoming the bottleneck in virtual machine deployment. Next is storage management issues. Guest OS storage operations behave as though accessing a real hard disk, but they cannot directly access physical disk. Like guest OS storage operate like though they are accessing a real hard disk, but they cannot directly access the physical disk. Multiple guest OSs may compete for disk resources when running on the same machine. Like multiple guest operating system may compete for disk resources when running on a same machine. Lastly, the storage management layer of underlying VMM is much more complex than traditional guest OS management. Lastly, we can observe the storage management layer of underlying virtual machine monitor is much more complex than traditional guest operating system management. Next is VM storage primitives. Operations like remapping volumes across hosts and checkpointing disks are complicated and sometimes unavailable. In virtual machine storage primitives, operations like remapping volumes across hosts, and checkpointing disks are complicated and sometimes unavailable also. Next is problems in virtual storage management. In this flooded VM images, large number of VMs in data centers create excessive VM images consuming significant storage space. In problems of virtual storage like virtual storage management, flooded VM images, which means large numbers of virtual machines in data centers create excessive virtual machine images consuming significant storage space. Next is storage management complexity. Current storage management techniques don't cater to virtualization needs, making it difficult to manage and optimize storage. Like in storage management complexity, current storage management techniques do not cater to virtualization needs, making it difficult to manage and optimize the storage. Solution in virtual storage management like Parallelx distributed storage system for virtualization. A customized storage solution designed for virtual environments aimed at simplifying management and improving performance. Like the Parallelx is a customized storage solution designed for virtual environments aimed at simplifying the management and improving the performance. Next is content addressable storage, which is CAS. Reduces the total size of VM images supporting large VM based systems in data centers. Like in content addressable storage, it reduces the total size of virtual machine images supporting large VM based systems in data centers. Next is federated storage VMs. Moves traditional storage features into federation of storage VMs that share physical hosts with VMs they serve, improving management and performance. Like in federated storage VMs, it moves traditional storage features into federation of storage virtual machines that share physical hosts with the virtual machines they serve, improving the management and performance. Like the federated storage VMs, improving the management and performance. We are going to look at Parallelx system architecture. Storage application virtual machine acts as a block virtualization layer between VMs and physical storage devices. Like the storage appliance virtual machine acts as a block virtualization layer between the virtual machine and the physical storage devices, provides a virtual disk for each virtual machine on the same physical machine. Like it provides a virtual disk for each virtual machine on the same physical machine. It supports various system virtualization techniques such as para-virtualization and full virtualization. Like it supports various systems of virtualization techniques such as para-virtualization and full virtualization. What is para-virtualization? What is full virtualization? I have already explained in the previous videos. You can go to the previous videos in the playlist and know about the para virtualization and full virtualization. Next is benefits of Parallelx. It simplifies storage management in virtualized data centers, reduces the storage footprint by reducing the size of virtual machine images, improves performance by handling virtual storage operations more efficiently. Like these are the some benefits of Parallelx where it simplifies the storage management in virtualization data centers. It reduces the storage footprint by reducing the size of virtual machine images. It improves performance by handling virtual storage operation more efficiently. Next we are going to see one example which has Parallelx providing virtual disk to client VMs from large common shared physical disks. In this example, we can observe the architecture of Parallelx is scalable and especially suitable for use in cluster-based environments. Like in the figure 3.2, 3.26 shows a high-level view of structure of Parallelx based cluster. A cluster-wide administrative domain manages all storage appliance VMs, which makes storage management easy. The storage appliance here in this figure we can observe the parallel-X is a set of like how the storage administration domain is there and physical hosts, what and all the parts in the physical host are present and shared block devices. We can observe that in this figure. And related theory is given below. You can go through this. Cloud OS for virtualized data centers. To serve as cloud providers, data centers must be virtualized. Like to serve as cloud providers, the data centers must be virtualized. Several virtual infrastructure which are VI managers and cloud OSs are designed for managing virtualized data centers efficiently. Like several virtual infrastructure managers and cloud OSs are designed for managing virtualized data centers efficiently itself. Here in this table we can observe VI managers and operating systems for virtualizing data centers. You can go through this. Next here in this example we can observe eucalyptus for virtual network of private clouds and some information related to is given. In this figure we can observe the eucalyptus for building private clouds by establishing virtual networks over VMs linking through Ethernet and Internet. You can watch this figure. Next in this example we are going to see VMware vSphere 4 as commercial cloud OS and some information related to the VMsphere 4 which came in April 2009 is given below. Next in this figure we can observe the vSphere 4 a cloud computing like cloud operating system that manages compute storage and network resources over virtualized data centers. Here in this figure you can observe the VMware vSphere 4 functions of VI managers create and manage VMs. The functions of VI managers are like they create and manage virtual machines, aggregate virtual machines into virtual clusters to provide elastic computing resources, virtual networks support Nimbus and Eucalyptus, dynamic resource provisioning and advanced reservations like in Open Nebula, virtual storage and data protection vSphere 4. Like these are all the functions of VI managers. Next is trust management in virtualized data centers. Role of virtual machine monitor in security. The virtual machine monitor hypervisor creates and manages virtual machines acting as an interface between operating system and hardware. The virtual machine monitor creates and manages the virtual machines acting as an interface between the operating system and the hardware. A virtual machine is fully encapsulated, meaning its entire state can be copied, moved, and deleted like a file. Like the virtual machine is fully encapsulated, meaning its entire state can be copied, moved, or deleted like a file itself. The virtual machine monitor is a foundation of security in virtual system, controlling how VMs access hardware resources. Like the virtual machine monitor is the foundation of security in a virtual system, controlling how the virtual machines access the hardware resources. Typically, one management virtual machine is privileged to create, suspend, resume, or delete other VMs. Like one management virtual machine is privileged to create, suspend, resume, and delete other virtual machines. Security risks in VMM based virtual environments. VMM or management VM comprise of if an attacker gains control over the virtual machine monitor or management VM, all VMs and the entire system are at risk. The security risk in virtual machine monitor based virtual environments are VMM or management VM comprise if an attacker gains control over the virtual machine monitor or management virtual machine, all VMs and the entire system are at risk. Random number reuse issue. Like in virtual machines can be rolled back to previous state, causing old random numbers to be reused. Like in random number reuse issue, virtual machine can be rolled back to previous state, causing an old random number to be reused again. This weakens the session key security in cryptographic protocols. Like by this, it weakens the session key security in cryptographic protocols. TCP hijacking attackers can occur due to reuse of initial sequence numbers. Like TCP hijacking attacks can occur due to reuse of initial sequence numbers. Next is VM-based intrusion detection system, which is IDS. In this, we can observe intrusion. Intrusion is the unauthorized access to a system via local or network-based attackers. Like the unauthorized accessing of a system via local or network-based attacks is called as intrusion. Intrusion detection system, which is IDS, detects and recognizes these unauthorized actions. IDS, like the intrusion detection system, is the detecting of the intrusion which has occurred through the unauthorized actions. IDS can be classified into host-based IDS and network-based IDS. In host-based IDS, it runs on individual virtual machines but cannot be compressed if the VM is attacked. In network-based IDS, monitors network traffic but may miss sophisticated attacks. Like host-based IDS runs on individual virtual machines but can be compromised if virtual machine is attacked. In network-based IDS, monitors network traffic but they can also not detect the sophisticated attacks. Next, in this figure, we can observe the architecture of live wire for intrusion detection using dedicated VM. For intrusion attack diagram, you can for this figure. In the example 3.14, EMC establishment of trusted zones for protecting virtual clusters provided to multiple tenants. Like some theory content is given below in this example, you can go through this. Next, in this figure, we can observe the techniques for establishing trusted zones for virtual cluster insulation and VM isolation. Like in this figure, we can observe the identity federation, virtual network security, access management, security information, and how the anti-malware, cybercrime intelligence, strong authentication, data loss prevention, encryption and key management, tokenization help in techniques for establishing trusted zones for virtual cluster insulation and VM virtual machine isolation. And some theory content about the figure is given below. You can go through this. Next, we are going to look at the advantages of VM-based IDS virtualization. Isolation. Even if a virtual machine is compromised, other virtual machines remain unaffected. Like in isolation, even if the virtual machine is compromised, other virtual machines, the remaining virtual machines are not affected by this. VMM security monitoring. The VMM can monitor and audit access requests for hardware and software systems. Like virtual machine monitor security monitoring, like it can manage and audit access requests for hardware and system software. Like it can monitor and audit the requests which are coming. Combination of HIDS and NIDS provides system level monitoring, which is HIDS, offers network level detection, which is NIDS. Two implementation methods for VM-based IDS are independent IDS process in each VM or a high privileged management VM. Like in this, IDS runs separately in every virtual machine. A privileged virtual machine manages the IDS function. Next, in IDS integrated into VMM, like in virtual machine monitor, full privileged access. The IDS is built into hypervisor and giving direct hardware access. More effective, but also increases the risk of compromised. Like in both, we can observe in this the IDS runs separately. In this, the IDS is built into the hypervisor. A privileged VM manages the IDS function. In this, more effective, but it increases the risk of compromisation. Next is additional intrusion prevention method. IDS logs. Analyzing attack patterns is critical. Logs are used for security monitoring but must be protected from tampering. Like in additional intrusion prevention methods, analyzing the attack patterns should be done first. After that, logs are used for security monitoring but they must also be protected from tampering by others. Next is honeypots and honeynets. Honeypot simulates vulnerable system to lure attackers. Like honeypot is a simulated vulnerable systems to, like honeypots make systems vulnerable, like it simulates vulnerable systems to lure attackers. Honeypots use multiple honeypots to analyze attacker behaviors. Like we know that honeypot lures the attackers. The honeypots use the multiple honeypots to lure the attackers and to analyze the attackers' behaviors. Virtual honeypots use virtual machines as decoy target to track attackers. Like in virtual honeypots, use virtual machine as a decoy, like a bait to the attackers. By this, they can track the attackers. So this is all about the last topic in the module 2 of cloud computing, which is virtualization for data center automation. I hope you understood the concept. Please download the notes if not downloaded from our website. The website link is in the description. Thanks for watching and stay tuned for further videos on remaining modules of cloud computing. Please like, share and subscribe to our channel.